Is that recording? Oh, it made a beep. Okay, so we're going to start 3-2, which is measures of variation. So for 3-1, we talked about measures of position, which is your mean, median, mode, mid-range. Hopefully I'll have markers that work. So measures of variation, kind of like let's do this problem, why we need this. So if we compare two outdoor paints, we're going to find the mean of both of this data on the left or on the right. I said left, that's awesome. Oh, I used to have it on the left and then I switched it so it looked better. Okay, so we're going to find the mean of all that data. So let's find the mean. So I have 10 plus 60 plus 50 plus 30 plus 40 plus 20 and divided by 1, 2, 3, 4, 5, 6. Divided by 6. And equals 35 for brand A. Then brand B, 35 plus 45 plus 30 plus 35 plus 40 plus 25. What'd you get for that one? It's the same thing. But if you had a choice, which brand of paint would you probably choose? If this was like the length of time that it stayed on. So this one, the lowest it had was 10, the highest it had was 60, the lowest this one had was 25, the highest this one had was 45. Are you going to take your chances and hope you get that 60-year paint that brand A had that one time? Or are you going to be, okay, well, the lowest I got over here was 25. Okay, that's why we need something other than the mean, median, mid-range, and mode. Because these are exactly the same thing, but when you look at the actual data, they're totally not the same thing. So we need something more. So that's why we need more. Range is the easiest type of measure of variance that we're going to talk about. I've got to find something for my board. So that measure of variance is quite simply for this one, just range is high minus low. 60 minus 10, that's 50. That's a pretty good sized range for that. The other one for the brand B data was 45 minus 25 for 20. Okay, you kind of know what to expect with brand B. Brand A, yeah, you could get really good stuff, you could get really bad stuff. Whereas if you look at this kind of data, when they kind of put little paint cans on a graph, you had more right around that 35 mark. Here you didn't really have any modal type of things. So which one do you really listen to? Okay, so range is the easiest thing. Let's find some more ranges. Why range really isn't the best thing is kind of what we're going to talk about here. Okay, finding the range of this data. I have my high is 100,000 minus my low of 15,000. It's not actually ordered. Okay, which I get a range of 85,000. Does that really tell you a whole lot? It doesn't really tell you about how much people made, because nobody really made 85,000. So the range isn't very helpful for this one. So now we're going to do, maybe we're going to do something. We're going to find variance and standard deviation. They're made from basically the same exact equations. Just what we call standard deviation is going to be the square root of the variance. So what we're always going to want to do is find our variance first. So the first thing we have to do, so there's lots of steps for it, find the mean of the data. So we already found the mean of this one. We're considering this a sample, so we use x bar. X bar equals 35. We already found that for this data. Okay. Subtract the mean from each data value. So now we're going to subtract 35. Subtract 35. Subtract 35. Subtract 35. I'm getting it all written out. And so sometimes it just takes up more room to write it out than anything else. So when I subtract it, I get negative 25. 25, 15, -5, 5, -5. Am I really bad at math? 30, yeah, no, that's right. Okay. Okay, so we subtracted that from each thing. Then we're going to square each of those numbers. So now do I want a thingy? Okay, so -25 squared is 625. All of these numbers are going to be positive. 25 is also 625. 15 is 225. -5 squared is positive 25. So all of these values are going to be positive. And another 15 is 225. We're going to add up all of those numbers. Okay, the way that that looks up, remember when we sum things, we use that E thingy, so we'll see that in our equation. I don't want to add. Are you adding? Okay, so that's 12, 13, 14, 15, 50, 1,750. So we summed up those squares. Divide that sum by the number of points we had. So how many points did we have? No, we're just actually 6 divided by 6. Divide that to get the variance. So whatever that number is called our variance. 291.6, and this is going to cover it up, I'm sorry. And if we want to know what we call the standard deviation, we take the square root of that 291. Okay, this marker might be going away. Yep, so take the square root of 291.6. 17.1. And so same general rule applies. So we needed to go to 17.1 because all our values were right here in the tens. Okay, standard deviation, I'm going to write, make sure you do like square root 291.6. Okay, don't round until that very end step that you do. That one probably didn't matter much when we take square roots. Okay, let me know when I can erase all that stuff. Okay, so now I'm going to give you the gross formulas. All the gross formulas mean we're going to do those same steps that we just did out by hand. We good? Okay, so we kind of did the wordy way. So of course we have to write it in gross equations that look worse, right? Okay, so our variance, we call that sigma squared. Sigma is the standard deviation. Okay, so sigma squared. What? There's another E, yeah. Usually, I'm trying to think of what I say. We use standard deviation a lot, and I think I usually end up doing like STD deviation is usually what I write. So if I write STDs on a lot of things, I'm talking about standard deviation. Okay. So this is the gross equations that we just did. Okay, so we found the mean. That was the first thing we did. That was the first step. Then we subtracted that, and then we squared it. That was our third step. Then we divided it. That was our fourth step we did. And I think our fifth step was finding the square root. Okay? It's mu. Yep. Mu is mean. Yep. Mu, 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 mu. Yep. Did lots of mu's. We're going to do lots more mu's here too. Maybe is this going to click? Clicky, 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 clicky. I know I have more. Okay. Now we're going to do paint B. Okay, so same sort of thing. Let's just try to read it off the equation instead of off of this piece. So our first thing to do is find the mean. Mean, we already did that. Mean was 35. Okay, minus 35, minus 35. Okay, I get 0, 45 minus 35, 10, negative 5, 0, 5, negative 10. Okay, same things. We're squaring those numbers now. Like, none of my markers are going to keep working at a continuous for like the whole thing. I just opened new markers and they were like all dry already and they're brand new. Okay, so we're squaring those numbers. 0 squared, 0. 10 squared, 100. 5, 25. 0, 25, 100. Okay, now we're summing those up. That's what this E dude means. That's really an S. Okay, and if you actually notice, so this is also a big sigma. This little dude over here is a little sigma. Okay, so we say like the sum of and variance. That's why we try to use the words instead of the things, so we don't have to say uppercase E thingy S. Okay, so now we've squared them. Now we're adding them up. So we're finding the sum of the x squareds, x minus mu squareds, is 250. 250. Okay, now we're dividing those by n, which we had 6 things still. Which, how about I write a 6 instead of an n? 41.6. 41.6. So that is my variance. Now I'm taking the square root. Yep. 6.4. Okay, which one of those had a lower variance? So do you remember what we had from the last one, if I can find it? I don't have. It was 22. It was 291.6. 291.6. So this one now, that was for A. So sometimes what you'll see is like a little a or something, sigma A. If I have sigma B is 6.4. Oh, I'm sorry, I wanted our standard deviation. So what was our square root of that was then 17.1. Okay, so, which we could see that just looking at the data and looking at the graph, but now we'll actually have a number value. With those number values, we'll be able to like compare a lot of different things. Okay, so which one had the least amount of variance? That's probably the brand you would actually pick. And we're going for that 6.1. We usually want a lower variance if we're like looking for a product. Okay, sample standard deviation is, that one say that? No. Okay, sample standard deviation is a little bit different than what we just did because we just did it treating like these 6 brands of paint were all the paint in the world, which that wasn't it because that was only 6 cans of paint. Really? Okay, so what we have is we actually have different equations, and it seems really weird to use these equations. Remember, x bar is the same thing as mu if it was a population. Okay, we're doing almost the same things, just make sure if you read sample somewhere in the question, that you're going to use this equation. Okay, so this is your equation for sample variance. So did you write that one down? Okay. Our sample standard deviation, we're doing the same thing, only taking the square root. Okay, x is each individual value, x bar is the sample mean. Remember, in a population, that's just mu. N is the sample size. In our big thing, we use a big capital N. Doesn't matter there. That's the same thing. The weird thing is, you'll notice, is I'm dividing by n minus 1. Okay? The reason like this was created, so like you're in calculus, so you kind of understand when I do like the derivative, I'm losing a power. So that's n minus 1. My power was n. My new thingy will be n minus 1. So it comes from some weird calculus derivations and stuff. So I'm sorry that it sucks. Everybody always asks, where does the n minus 1 come from? Most people haven't taken calculus beforehand to realize where that's kind of coming from. I might show you guys later on, but you still have to learn a few more chapters of stuff. Okay, so there are shortcut formulas because these ones are grosser. Okay, so write down your shortcut formulas as well. I don't know why they necessarily always think one is grosser than the other. So most of your questions in the book, you're going to be using these. You're going to be doing sample variants, so you're going to use these shortcut formulas. I have to get really a lot better at sniffling because I sniffle a lot, and that's gross. It's gross to hear on the videos. So let me know when you get it down, and then we'll do a problem with it. And I think, do I have it on the next slide? I can't tell. I do, but they're tiny. Just so that we can kind of look at them. I don't know if it's going to look good on the next slide. Maybe this doesn't look good on the online thingy. Okay, so now we're going to use those shortcuts. So the first thing we're going to do is find the sum of the values. So did I put some data on here? Maybe. Not till the end. Then we're going to square each value, find the sum, plug into our formula, give me some data. Then we'll need to do the square root if it asks us to. So find the sample variance and standard deviation for the amount of European auto sales for a sample of 6 years shown. The data are in millions of dollars. Okay, so we're going to find the sum of the values. So we're going to have all of these guys added together. Okay, and we'll write that sum of the values is equal to something. Anybody adding? No? Yeah. Yeah, you guys are good. Okay, 22, 23.1, 55.1. You're going to get there faster. Sorry, I was writing down what I was at. So 75.6 is my sum of my x values. Then we need to square each value. Not this number. We'll do that in a little bit, but we need to square each value. So 11.2 squared is 121.4. 121.8. I don't know if I'm right on that one. I don't think I'm right on that. I don't know if that works. So square some numbers for me. Square some numbers for me. Square. Yep. Each one separately, and then we'll write them all down. 0.44. Oh yeah.
163.84.
Okay, now we have to add all of those guys up. And how we write that? That will be the sum of the x squareds. Okay, where these things are going in your formula. So this guy with the x squared inside the parentheses is that one. This one with the x squared outside the parentheses, we're putting the 75.6 inside and we'll square it eventually. So our number of points, 1, 2, 3, 4, 5, 6. So we have 6 times the sum of the x squareds, which was that 959.24, plus, or minus, sorry, that 75.6, we'll square that, all over 6 times 5. So 6 minus 1 is 5. And if you're plugging that in your calculator, make sure you get like a whole parentheses around the top. Anybody? Come on. Chop, chop, Taryn. You want me to stay right here?
Yeah.
Okay. Yep. So I think like the most amount of time is typing in the calculator. Not negative. Yeah, so you have like parentheses, 6 times that stuff. Minus, and then did you do 75 squared? That should be
75.6 squared is 5,715.
do we get, that's weird. So what do we get? 5,000, oh, 958 times 6 should be 5,753. 6 times 959.24? Did you?
Oh, I did.
That? Yep. So if you actually, like, if you do type it all in, I mean, the only thing you really need to remember is this whole top is in parentheses.
Okay.
But you should get, okay, so that first thing was 5,753 point something, 64 minus that 5,715, is that what you found it was? 0.36, all over 30, and then you'll subtract those guys. 55. They have 0.94 in the book. So we're gonna say that's what it is, but we might have rounded wrong, they might have rounded wrong. Either one. Okay. 55, so you got a bigger number, that's kinda cool. So then do that thingy, and it says you get 1.276. Okay. So we have that guy is our variance. So variance, if we wanted to then find the standard deviation, we're taking the square root of that. Okay, one more. I have so many different things to click. Okay, then with those, with standard deviations, we have what is called the empirical rule, also sometimes called the normal rule. With that, all that's saying, and reason why standard deviations actually are an important number, is 68% of our data lie within one standard deviation. So this graph kind of shows it a little bit. So this whole point right here, these 3 little columns, there's 68% of the data. Okay, so remember these numbers. We have 68% within one standard deviation, falls within one standard deviation. Okay, 95% within 2 standard deviations. So if I erase those lines, then I would have 98% within these little guys. 95%, sorry. Okay, then if I kind of just want to do 3 standard deviations, whoops, I kind of have my lines messed up. Okay, 3 standard deviations, 99.7. So that means almost all of data that's normally distributed, which we'll talk about in a later chapter, we'll do tons of normal distributions, is within 3 standard deviations. If you have weird standard deviations, if you get like 100 for your standard deviations, no, that's just like wrong, okay? There's no rule that says it has to be within like this many things, but almost all of your data is within 3. If you got like a 5 or a 6 for your standard deviations, that wouldn't be like completely unheard of. It would just be like some really crazy data that you're getting from that point. So we will find some data for, or we'll do a little bit with this guy. Let me see what I have next, or is that it? That's it. Okay, so just remember, sorry, I was thinking about tomorrow's stuff. Sometimes I don't know what you have to do with this. Well, I know what you have to do with it. I don't know what you have to do with this in this homework. So I will have you guys do homework in section 3.2. And I will also make sure, in case you didn't hear me, so Sean, to stop at number 20 for your quiz in chapter 2. It's weird. I wonder what that will sound like when I get those questions. And I'll put questions online.